Hey guys, so today is September 9th, and we are starting on a new topic titled Scientific Notation. So remember that everything I write, you should be writing in your journals as well. So scientific notation is a way to write very large or very small numbers. So scientists and mathematicians needed to find a way to write very large or very small numbers in a shorter way where we don't have to write all of its digits. And so they found a way to do this, but of course we do have a couple of rules that we have to follow in doing this. So I'm going to go ahead and color code these rules so that when we get into the practice, you will see where we're using these rules. So one of the rules was that the base number, or the base decimal, must be between 1 and 10. And the second rule is that we have to multiply that decimal by a power of 10. So whatever decimal we're using, that just means that we're going to multiply by 10 to a certain degree. And it might not make sense now, but it will in just a minute. Go ahead and write these notes, and I will give you 1 minute so that we can get started. Alright, so what do I mean by very large or very small numbers? So, if I were to ask you, what do you think the population of the United States is? Do you think that would be a very large number or a very small number? So we know that there are many people in the United States, so of course that would be a very large number. And in fact, the population of the United States is approximately 328,200,000 people. And so that number would be written like this. So a regular way to write a number is called standard notation. And I'm just going to go ahead and write that down just so that you remember that's a regular way to write a number. And we are going to try to write that number into a smaller version of that number that still equals that number, but it has a base with a decimal that is between 1 and 10 and is multiplied by a power of 10. So let me show you how we do that. So the first step, and I'm going to go ahead and put that in purple because that's my very first criteria. Actually, let me circle that. Is to create this number where I have a number between 1 and 10. For example, if I were to put my decimal right here, that would convert my standard number into 32,820,000. That's still not a number between 1 and 10. So let's say I were to put my decimal here. Well, now that would convert my number into 328,200, right? And so I am always going to turn that number between 1 and 10 by putting a new decimal between the first two digits right here. So if I were to put my number, my decimal right there, I get 3.282. And I'm not going to write those zeros. So that is my first step. My second step is to write this into a power with a into a power of 10, or multiplied by a power of 10. So I'm going to go ahead and write that down again. 3.282 multiplied by 10, but I need to know what exponent goes there. What is that little number on top? What is the value of that power? So that's going to be very easy. I'm going to show you guys how to count. We're going to count from our decimal, and we're going to count 1, 2, 3, 4, 5, 6, 7, and 8. So that means that in scientific notation, this number, 328,200,000, is written as 3.282 times 10 to the power of 8. Now don't worry if you didn't get that, we're going to try that again. Alright, let's try to write how far we are from the moon. We are actually 238,900 miles from the moon. So let me go ahead and write that down. 200. Alright, so my first step is to turn that number into a decimal between 1 and 10. So I'm going to put 2.389. And I'm not going to write those zeros in. And my second step is to count how many places there are after that decimal. 1, 2, 3, 4, and 5. So this is written 2.389 times 10 to the power of 5. So my standard notation for 238,900 is written in scientific notation as 2.389 times 10 to the power of 5. And we always want the same format, okay? We always want the format: a number, a decimal, and as many numbers as you need, times 10 to an exponent. All right, let's go ahead and try one more example. Let's try to write this number in scientific notation. So the first step, just like any other, is to convert that very large number into a number between 1 and 10. So first I'm going to go ahead and put that decimal right here. So this would be 5.67. And my second step is to count how many digits are after that decimal. So I'm not counting zeros, I'm counting place values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would write that as 5.67 times 10 to the power of 10. And again, one of the biggest mistakes that students make every year is that we count zeros, and that is not correct. So again, I'm just going to write a note on there. So we are not only counting zeros, okay? And an emphasis on not. What do I mean by that? I mean that if I put my decimal here, I am not counting 2 zeros and I put a 2 as my exponent. I'm counting 1, 2, 3, 4, 5. We're counting place values, okay? If I put my decimal here and I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's why this is a power of 10. There are in fact 8 zeros, but that has nothing to do with what we're doing here. Okay, we're not counting zeros. So the same is true for values that are very tiny, very small numbers. So let's think of, for example, the radius of a grain of sand. So if you guys like to go to South Padre Island, you see one tiny little grain of sand. It is actually 0. Put that in blank. 0.062 millimeters wide. That's the radius of it. So what am I going to do? So I do have to follow the same rules as before. And what were my rules? My rules was, 1, it has to be a number between 1 and 10. So that was my first rule. And my second rule is that I'm multiplying it by a power of 10. All right, so where can I place a new decimal so that it is between 1 and 10? So remember that I want one number, a decimal, and then as many other as we need. So in this case, I cannot put 0.062 and then put a decimal. I also cannot put 0.062 and then add more. I can't do that. I have to work with what I already have. So I know that I can put my decimal between the 6 and the 2, and that satisfies that first rule. It has to be a number between 1 and 10. My second rule is that now I'm going to count how many place values. But unlike larger numbers, I was counting places to the right. In this case, I'm going to count to the left. -1, -2, until I get to this old decimal. So I'm going to put 6.2 times 10 to the -2. So this is written in standard notation. And in scientific notation, it is written as 6.2 times 10 to the -2. Let's go ahead and try another one. So here we're going to talk about the diameter of your hair. And obviously it's very, very tiny, right? The width of your hair. And so the diameter of your hair is 0.00254 centimeters. So let's think of, where can I place my decimal so that this number is between 1 and 10? At first thought, I think, well, why don't I just put it here? Well, if I look at that value, that's actually 25.4. So I cannot put that there. So what I can do is I can place it between the 2 and the 5. That gives me 2.54. That is a number between 1 and 10. And then the second thing I'm going to do is I'm going to now count place values going back to my original decimal. Okay, this is where I'm going to stop. So I'm going to count -1, -2, and -3. So this is going to be 2.54 times 10 to the -3. So as scientific notation, this would be written as 2.54 times 10 to the power of -3. All right, let's go ahead and try one more. 0. And so again, my very first step is to write that number as a number between 1 and 10. So I know that I can put my decimal here, 1.3625. And you want to make sure you write all of that out. And my second step is to count the place values. Again, we are not counting zeros in between. We are counting place values. 1, 2, 3, 4, 5, and 6. So this is a -6. So this is going to be 1.3625 times 10 to the power of -6. So in scientific notation, this is equal to 1.3625 times 10 to the power of -6. All right, I'm going to do 2 more examples just so that you can see both of them side by side, the positive and the negatives. So let's go ahead and look at this number and this number. So following my rule as before, first I'm going to place my decimal in the middle of my digit where it becomes between 1 and 10. So that's 1.23. And my second step is to count how many place values, 1, 2, 3, 4, 5. So this is going to be times 10 to the power of 5. And you see how I did those 2 steps in one line? And so that's going to help you guys a lot so that you guys can practice. Okay, let's try the same thing for the next one. I want to write this number between 1 and 10. So I know it goes here. 1.23. And then I'm going to go ahead and count my place values, not counting my zeros. 1, 2, 3, 4 times 10 to the -4. Now, how did I know that it was going to be a negative and not a positive number? Well, notice here I'm counting to the right, and notice here that I am counting to the left. let's try 560 again. That is a very large number as well. So I would put my decimal between the 5 and the 6. And I'm going to count all the way to the right. 1, 2, so it's times 10 to the power of 2. That is a very small number. So again, where do I put my decimal so that it is between 1 and 10? I cannot put it between the 0 and the 1 because that's less than 1. That means that I have to put my decimal right here at 1. Now I'm going to go ahead and count. -1, -2. So it's times 10 to the power of -2. Alright, so that is all for today. Tomorrow we're going to learn how to go from scientific notation back to standard notation.